2.5, day 2. We'll be looking at the number of zeros of a polynomial function and then being able to find them by factoring or using the rational zero test. If a polynomial is of degree n, let's say third degree, where 3 is greater than 0, then f has at least one 0 in the complex number system. Remember, a complex number is a combination of real numbers and imaginary numbers. This is the part that we really need to know. If f of x is a polynomial of degree n, where n is greater than 0, in other words, positive, then it has exactly n zeros, including multiple zeros. So if it's a degree 4, it will have 4 zeros. Degree 6, 6 zeros. Degree 5, 5 zeros, and so on. So let's look at this, finding the zeros. It's a quadratic, so let's predict. Degree 2, it should have 2 zeros. Okay? I cannot factor this. I don't want to complete the square because that middle term is odd. So I'm going to go to the quadratic formula. Opposite b, plus or minus square root b squared minus 4ac all over 2a. Okay, so we have the quadratic formula there. Now let's just do the math. X equals 3 plus or minus square root 9. 4 times 2 is 8 times 5 is 40 minus 40 over 2 times 2, 4. X equals 3 plus or minus square root negative 31 over 4, which, because that's now a negative root, I'm going to pull that out as a I. Square root of 31 does not simplify over 4. How many zeros does a function it have? That has 2 imaginary complex, 2 imaginary zeros. Okay, so yesterday in class we reviewed some factoring techniques. So that's what I'm going to try and do is factor this. And I'm going to try and factor it by grouping because it's a degree 3. If I can't factor by grouping, then I would go to the rational zeros test, P over Q, to find a 0 and then go from there. So let's try by grouping first. Okay, so out of my first binomial, I can factor out an x squared. I'm left with x plus 4. Out of my second binomial, I can factor out a 9, and I'm left with x plus 4. Now, out of the whole function that I have still there, I can factor out an x plus 4, and I'm left with x squared plus 9 equals 0. Now, using zero product property, x plus 4 equals 0, x equals negative 4. X squared plus 9 equals 0, x squared equals negative 9, x equals plus or minus square root negative 9, x equals plus or minus square root 9 is 3, and since it's negative, I. So how many zeros do we have? We have 3 zeros, degree 3. The zeros, I have one real and 2 imaginary. Again, I look at this and I say, can I factor it? If not, then I go to the rational zeros test. This I can factor it. It's both a combination of a quadratic form and difference of squares. That's my difference of squares. So now I can factor it to 4x squared minus 9 and 4x squared plus 9. Now, because it's of a squared form here, I could go ahead and use the square root method since I have just the square and the linear term, or not the linear term, the constant term. So add 9 to both sides, divide by 4, take the square root. Square root of 9 is 3, square root of 4 is 2. So there's two real solutions, two real zeros. How many zeros do I need to have? I need to have 4. So I come over here to my 4x squared plus 9 equals 0 equals a negative 9. A negative 9 fourths, square root both sides. Okay. Square root of 9 is 3. Square root of 4 is 2. Square root of negative 1 is I. So I have two real zeros, and I have two TWO imaginary zeros. This again is of that quadratic form that we talked about. I could factor this to x squared plus 1, x squared plus 9 equals 0. Now I'm going to solve square root method. Squared plus x squared plus 1 equals 0. Subtract the 1. Square root. Square root of negative 1 is I. Do the same thing for the x squared plus 9. Subtract 9. Take the square root of both sides. Square root of 9 is 3. Square root of negative 1 is I. In this case, I have 4 imaginary zeros. So the next problem, if I look at this, x to the 4th minus 3x squared, blah, 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 okay? Since it's x to the 4th, and there's 5 terms, I cannot yet use factor by grouping. I cannot use the quadratic form. So I cannot have a factor. I don't have a factoring technique yet. So what I have to do is list the possible zeros. Again, since it's all over 1, I just need the factors of 60. So I'm just going to list the possibles. Plus or minus 1 and 60. 2, 30. 3 and 20. 4 and 15. 5 and 12. 6 and 10. So now I'm going to start guessing and checking on this. And I may do some erasing. Okay. I'm going to go ahead. I'm going to start with, because 60 is at the end, I'm going to start, instead of with 1, I'm going to start with 2, 1. 2 times 1, 2. Negative 3, negative 1. Multiply, add, multiply, add. Okay, so I'm getting close, so I'm not going to go back to 1, and I'm thinking I might try 3 next. Again, it's complete guess and check. So this one didn't work, so I'm going to try a 3. Okay, so that one didn't work. So let's start over with 3. And then multiply, add, multiply, add. Okay, because my remainder is 0, 3 is now a 0. Now I rewrite this as a polynomial function or equation, x cubed, because I started with x to the fourth, so this is x cubed plus 0x squared plus 6x plus 20. Well, I don't know how to factor that. So then I have to go and test another 0. I already tested 2, but with 2, I ended up with a positive 20. So I'm going to try a negative 2. So now I'm going to go and try a negative 2. I'm going to test it on this function, 1, 0, 6, 20. Remember, I have to put the 0 in for the x squared term. Bring it down, multiply, add, 0. So now I have 2 of my zeros. Let me start a little column over here where I'm listing them. My zeros I have are 3 and negative 2 so far. So I have 2 real zeros. Okay, so now what do I have left? I have x squared minus 2x plus 10 equals 0. It's not factorable, but my middle term is an even number, so I'm going to go ahead and complete the square. X squared minus 2x plus something equals negative 10. So negative 2 divided by 2, negative 1. Negative 1 squared is 1, so I'm adding 1 to both sides. This factors to x minus 1 squared equal negative 9. Square root both sides, plus or minus square root negative 9. Add 1 to both sides. Square root of negative 9 is 3. Square root of the negative 1 is I. So my other 0 in my list would be 1 plus or minus 3i. So I have 2 reals, or 2 rational, 2 real, and 2 imaginary zeros. Let's do one more. Find all the zeros of. Again, it's not a factor by grouping. I can't use my quadratic form. All those things would start out easy, so let me list my possibles. Because my Q term is 1, I just have to list the possible zeros. I just have to list the factors of 32. And I believe that would be it. Okay, so I'm going to go up here and I'm going to start my guess and check. 1, negative 7, 16, negative 8, negative 32. Okay, let's go ahead. I got a negative 32. So I'm thinking I might need an even number. I don't know. So I'm going to try 2. 2 times 1 is 2. Again, add. Okay, so this one does not work. 2 does not work. And so I'm thinking, well, negative 2 probably won't work. So let me try 1. So that's 1. Okay, so that's not close either. Well, now I'm stuck. So now I'm just going to start randomly guessing and checking. 1 didn't work. 2 didn't work. Let's try 4. So that's 4. All right, so there, start my list in zeros. So 4 works. Now I come down and I look at, what do I have left? X cubed minus 3x squared plus 4x plus 8 equals I look at this, out of this, I can factor an x squared. Out of this, I can factor a 4, but it won't help me. So I can't factor what's left by grouping, so I'm going to have to do another guess and check on that. All right, so I tried all the positives. I tried positive 2, positive 1. Let's try negative 1. Negative 1 on 1, negative 3, 4, and 8. All right, so negative 1, part of our zeros. Now I'm left with x squared minus 4x plus 8 equals 0. That is not factorable. Okay, since that's not factorable and my middle term is even, I'm going to go ahead and complete the square. Negative 4 divided by 2 is 2. 2 squared, 4. Add 4 to both sides. Square root both sides. Add 2 to both sides. Square root of 4 is 2. Square root of negative 1 is I. So back in my list of zeros, I have 2 plus or minus 2i. There again, I have 2 reals and 2 imaginary zeros. Solution